So today what we're going to do is go over the replacement rules and go over the two tactics that we learned recently, CP and IP. So I've got a list of 7 proofs here that I'm going to go through one at a time. These should all be familiar because they're all from your homework. And I'm just going to go through how I solved them. Please remember that proofs can be solved in multiple ways, so if you did not solve them this way, that's totally fine. It's totally normal to have multiple ways to solve a proof. This is just how I did it. And in the process of solving these 7 proofs, I'm going to show you how to use all 10 of the replacement rules, plus the 2 CP and IP. Let's go ahead and get started. Here is our first proof. We have a simple conclusion, which means primarily what we're going to be doing, we've got just the letter right here, which means primarily most of this proof is probably going to be breaking down all of these to get to that. I see P right here in the first premise, so I'm going to try to break that apart first. Since I don't have any pieces to do that, I need Q or R. Let's look at the other 2 premises. I've got not R here, and then I've got this implication set up. That not R is the opposite of this, which means I can do MT. So I think I'll start there, which gives you the negation of the other side of the implication through 2, 3, MT. Since it's an OR on the inside, I can break it apart by doing a DM, because that'll turn it into not S and not Q for DM. That is De Morgan's rule. That works by whatever you have here in the parentheses, this symbol flips to this. It also goes vice versa. It goes backwards as well. So you can turn this into this. You can go back and forth between these 2. De Morgan's rule, all of the replacement rules work both ways. So you can go either way across it, but you have to use, just like the implication rules, you have to use the symbols that the replacement rule says to use. These are the only 2 symbols that it works on. You can't do De Morgan's rule on implications. You can't do De Morgan's rule on biconditionals. So that gives us De Morgan's rule right there. Now that I have De Morgan's rule, I can simp. I'm still seeing this error. I don't know why I'm still seeing it. I've put like 100 comments on homeworks and classworks. But I'm still seeing people trying to simp from implications. Remember, you can only simp from AND, which is this symbol right here, this arrow pointing up. That's the only one that you can simp from. I don't know what's going to be useful to me, so I'm going to simp from both sides. I've seen a few people doing this thing where they use COM to flip this and then they simp it. You don't have to. You can simp from both sides just the way it is. Alright, now I have not Q and not S. Well, if I get the opposite of this, then I can do MT, which will give me not P, and then I can DN that and give me P. So, how can I make this? You cannot just do add and add R to this. The reason why is because if you do that, you're not going to have the negation. The negation is going to be on the inside of parentheses instead of the outside, so that's not going to work. But I do have not R right here, so let's do a conjunction in DM. Not Q, not R. That is 3, 7 conjunction, and then we can DM that. We can De Morgan's that, so it takes the negation on the outside, flips the symbol, puts it on the inside. That's 8 De Morgan's. And now we have the negation of this side of the parentheses on line 1, this side of the implication on line 1, which means we can do another MT, just like we did on line 1, which gives us not P by 1, 9, MT. Then we just have to do a double negation on 10, and we get our conclusion. So that shows you how to do De Morgan's. We've got De Morgan's right here. So there's De Morgan's, so you have that one. Got another De Morgan's going on right here as well. So you can see how that works. We also had a double negation right here. It's another replacement rule. So now we've seen those. Let's move on to the next proof. We've got this one now. We've got a slightly more complicated conclusion this time. And it's not the same as in here either, because that's P and that's R. So those aren't going to work. Well, we can flip it. We can move around that parentheses a bit. There's a rule called association we can use to play around with the parentheses there. The only reason why association would work here is because these 2 are the same symbol. Remember, that's the only time that that works. Association does not work when these two symbols are different. The one on the inside of the parentheses and the one on the outside of the parentheses has to be both either this, the or symbol, or the and symbol. That's the only symbols it works on. It does not work on implication signs. Association does not work on implication. If we want to put Q or R on the inside of this parentheses, we need to flip these two. Let's do an association. Remember, please don't put as there, just put assoc. And then we can do a com on the inside of the parentheses. This is the biggest difference between rules of implication and rules of replacement, which is that you can use rules on parts of lines rather than having to use rules on the full line. In rules of implication like simp and conjunction, you have to use it on the entire line. You can't just pull little things out. But for rules of replacement, you can use them on just parts of lines. Like this one here, which is just using the middle right here, rather than the entire line. Now we're going to do another association, which is going to put that Q back into the parentheses, and that gives us it in the parentheses just like we wanted. Okay, well now what? Now we still got this P to deal with. We still got to get rid of that. Well, we have not P as premise 1. This is a disjunct, which means we can use disjunctive syllogism. Disjunctive syllogism only works on disjuncts. It's if you have the negation of either side, you get the positive of the other side. So Q or R by 1, 5, DS. Bam, done. These parentheses, they're not necessary, so you can get rid of them because it's the entire line is in parentheses, so you can get rid of that. Some people are still leaving them. It's fine. Logically, it's equivalent. It's just you just need to know that you can play with it on the inside of the parentheses there. So I tend to take them away if the entire line is in a parentheses. Ooh, we've got a biconditional here. There's only one rule that works with biconditionals, and that's material equivalence. It's the only one. It's the only rule you can use. So we know we're going to do a material equivalence on this right off the bat. But the question really that arises in this is which of the two material equivalences we should use, because there are two. There's the material equivalence that turns it into implications, and there's the material equivalence that turns it into conjunctions. So which one do we want? Well, let's just start with the implications and see where it gets us. So you do first implies the second, and the second implies the first. So that's one equiv. Now I'm going to simp it because that's just what my instincts tell me to do whenever I see it separated off like that. I don't know what's going to be useful, so I'm going to take both sides. Alright, now what? Well, look at that. We've got not R implies not T. We've got R implies T here, but we've got T implies R, which means we can do something called tran. That will flip it on the other side and negate both sides. So we'll get not R implies not T. Notice how that works. You flip it across, you rotate it around so that this side goes on this side and this side goes on that side, just like this, and then you negate both. That's how trans works. And it only works in implications. Remember, these rules only work on the operators shown in the rule itself. Now we have that. And now we can use that for an MP right here to get the other side of that. I don't know what use that's going to be to us, but whatever. Just breaking it apart. 2 and 6 MP. Okay. I see a conjunction, which tells me immediately my instincts are like, simp it! We've got, it's a disjunct, which means we can just add, which means that is immediately what I'm going to do. I'm just going to add it. Bam, done. We have an ugly conclusion. I don't like that. Well, we've got implications on both sides, which means association's not going to work, but there's another rule that does something like this. What is it? Exportation. That's right. So we'll use exportation here. Exportation works by moving the parentheses around situations like this. But you have to be careful because it changes the symbol on one of them. Like that. And that is one export. So remember, rules of replacement, you can go either way between these two, it's fine. You can either go from this to this or from this to this, either way, but it leaves the implication sign that was in the parentheses when you're going from 1 to 3. You leave this one alone, but you flip this one into a conjunction. Well, we've got the negation here. Oh, MT, MT, MT. We've got the negation of that side, which means we can get the negation of the other side, which is the conclusion. This one was really easy. So do you see how that works? So you've got this here, and then you've got the negation of that right here, which gives you the negation of this part. And there's MT. That was simple. Alright, let's move on to these down here. Don't have a lot to work with. Well, I see the same letter can join together, which means I can do a tautology. Now, this negation sign on the outside is completely unaffected by the tautology, because the tautology is only actually happening to what's going on the inside of the parentheses right here. So the negation stays on the outside, we get P as a result. If this had been more complicated, if it had been like two parentheses put together or something like that, this negation sign would still be on the outside, so you'd have to use big box brackets. But thankfully in this case, it's actually really simple. So one taut. As you can see, this tautology is being applied just to right here. It's just the inside of that line there. It's not the entire line. Please be careful of that. Those negation signs really do matter for stuff like that. Replacement rules can be used on just the interior of a line, so we're good with that. But now what? Okay, we've got Q. Q doesn't appear anywhere in this problem, so we know we have to add it, because that's the only rule that lets you just come up with random stuff out of nowhere. So we're going to add Q, and then we need it to be an implication. We've got a negation, and we've got a disjunct right here, which means we can use implication. So P implies Q, 3 impl. The way that works is that this and this turn into this. So those two together turn into this. So you lose the negation over here, and then this disjunct turns into an implication on this side. So I just need to show you distribution. So I'll do that in these. And I think I'll use CP and IP here. So let's start with CP. Why would I want to use CP in this one? Because the conclusion has an implication in it. So CP is really easy on problems like this. So, well, usually. So we'll start by assuming the first half of the conclusion, this part right here. This is what we'll assume. Because when you close a CP, you get whatever you assumed implied by whatever the last line of the CP is, which means we're going to aim to find Q on its own so that we can CP those together. Okay, now, because it's a CP, we have to indent. The thing about the indentation is there to remind you that you're inside of a CP and you still have to close it off. So every time that you do a CP, you indent further and further and further to remind yourself you're still on the inside and you still have to go outside, which means you have to finish, you have to close off the CP before you can just be done with the problem. So we've got an assumption here, we've got to end it. Hopefully we will end it with Q, and that will be how that CP ends there. Okay, this is a bit of abstract thinking here, but constructive dilemma, crazy as this is going to sound, a constructive dilemma between these two implications, this one and this one, these two big implications, would result in C or P, and would use it, and then we could get these two disjoined together. Why would we want that? Because then we could reduce these two to get Q out of that. It sounds crazy. I know. But just, you'll see what I'm talking about. So we're going to conjoin those two together. So we're going to start with S because it's on this side. So that's the one we need to start with. Still in the CP. Okay, now we can use this. Do you see this is here and this is here? That means we can use that for a CD. constructive dilemma, which will give us by 2 and 4 constructive dilemma. Again, that was taking this here on this side of this implication sign, and this one here on this side of this implication sign, and we get the other sides of the implication sign. So this goes here, and this goes here, and they're joined together by a disjunct, just like this one was. Now we have Q on the first part of either of this. This construction right here can be used for distribution. It can also be flipped. It can be the or here and here and the and right here. But it's like this. So in this situation, we can do a distribution, which will take that Q out of the problem. So look at that. Whatever was on the inside of the parentheses goes on the outside of the parentheses now. And whatever was on the outside of the parentheses now goes on the inside of the parentheses. Just like that. That is 5 distribution. Bam. There's our last rule of replacement. Now what? Well, we have an and right here, a conjunction right here, which means we can just simp it. Okay, we have that Q that we wanted, right? So this and this match. And this is what we assumed right here, which means we can now close this CD, this CP, and the result of that closure will be whatever we assumed implies whatever the last line of the assumption was. And that is 4 through 7 CD. Sorry, CP. And so this is here, right? And then it's implication, and then this is here. Do you see? That's how CP works. All right, now we'll use IP, indirect proof. The reason why I want to use indirect proof on this one is because it is a simple conclusion. The conclusion is just one letter, which means an assumption IP would be really easy. You do negation, and then you do whatever the conclusion is. If the conclusion has negations in the front, you still just put a negation right here, and then just put whatever it was exactly the way it is right there. So that is assumption IP. We're going to indent just like you do with a CP. You indent. All right, now what can we do with that not L? Can we do anything with that not L? Well, we've got S implies L. Yeah, we've got an S implies L. I don't know how that's going to be useful to us, but right here we've got this conjunction right here, see? Which means we can simp it out. So we'll just simp that out of line 1. Cool. Don't know how useful that's going to be. Oh wait, look. Negation and an implication. It's the backside of an implication, which means we can just MT that. Bam. Not S. I don't know what use that's going to be to us, but whatever. 3 for MT. I have no idea why we needed that, but we needed that. The point of IP, what you're trying to do with IP, is to find a contradiction somewhere in the problem. So we have S here, and we have not S here. That's a contradiction. You can't have both of those in the same problem. So what you do to close an IP, see with a CP, you combined this goes here, and then this goes here. That's not how IP works. With IP, you conjoin. It always ends in conjunction, the operator conjunction. So you get this, and we're going to conjoin them together. So S conjunction and S, 2 and 5 conjunction, and that closes the IP. And the way that you close it on the outside is that you take whatever this is and you just negate it. Just put another negation sign. Even if this already had negation signs, does not matter. You slap another negation sign right there. And that gives you 4 through 6 IP. Now our conclusion is just L, and the IP gave you not L. You'll always end, like the last thing you'll do with a proof that you used IP is a double negation to get rid of those extra negations. Bam, done. And that is IP. That's how IP works. I hope this was helpful. I know that a lot of you are having trouble with overthinking. with overthinking, I used to have this trouble too. You'll notice that in this whole thing that I've just done, this past however long this video is, this past 20 minutes, I've literally not strategized at all. I just ran with whatever I saw. I was like, oh, look, there's that rule. Let's just do that and just see what happens. That's really helpful when you tend to overthink. I tend to overthink, and that's what I do to make sure I don't overthink it. And then you solve proofs really fast. You just do it mechanically. Just turn it into a mechanical skill that you don't even think about, and you just do it. And that really helps with overthinking. Some of you have indicated that you're having problems with like figuring out where to start. Just pick a line. You guys have 18 rules at your disposal now. You can do something to every line, especially with the rules of replacement. You can do something to everything, so just pick a line and just start going. Just run with it and see what happens. And most commonly, as you do this more often, you will be able to unconsciously see strategies, and it'll just happen naturally. You just have to let it happen by just starting. But you're never going to get anywhere unless you start the proof. So just pick a line, any line, and just start going. I tend to favor picking the first line, but whatever, it doesn't really matter. The final exam should be up very soon. I'm planning on finishing it tomorrow. That quiz is due, and then I'm planning on finishing the exam on Saturday and putting it up on Sunday. Maybe, hopefully, I can just put it up as soon as possible. I just need more people than the 9 people who've done that quiz to do it. Like, I need at least half the class to do that quiz before I can do the final exam. I think I know what I'm going to do for the final exam, but I'm not 100% sure yet. So, please do that quiz as soon as possible. The quiz that's assigned for today, Friday. Please, quickly. So that I can make the final exam. Alright, I hope this was helpful. Remember that CP and IP are optional. You don't have to use them if you don't want to. They're shortcuts. Because otherwise these proofs would be really long. So, yeah, that's it. Thanks for watching. Bye.